Okay, we are now recording. So I will share my screen. Let's see what we've got on the lesson plan for today. Aha, lesson 6. So we're going to do sweep along a guide. We're going to talk about planes, axes, and shelling. Hopefully we'll wrap up a little bit before the end of class. You guys can start the homework and get questions answered. So, sweep along a guide. So far we have done extrusions where we drew a closed region and we just pushed it out in a straight line to create a solid body like this piece of rod that I'm showing. Okay, that was an extrusion. Then we decided we're going to draw a closed region and we're going to spin it around some kind of a hinge point or axes. And those were the bodies of revolution. Those were, you know, the wine bottle, the donut, all of that stuff. And those were fun. Today, we're going to do something different. We're going to do a closed region and we're going to push it along an irregular pathway. And these are called sweeps.
No.
So you can imagine this circular pathway, or excuse me, circular profile goes along this linear guide. And the thing about it is that this profile always stays perpendicular to the guide. So as we come along, as we come into this rounded section right here, it begins to tilt back on itself, which is what you're seeing right here. The profile stays perpendicular going up around the top, it creates the hump, and then it goes back and stays straight toward the end. Okay. If you guys want to follow along with me in the lesson 6 folder, we have something called a Jeep frame. Why don't you go ahead and grab the Jeep frame, download that. And when you open it, you should have something like this. You should have a sketch 1 and a sketch 2. Uh-oh. I might have to re-download mine. Okay, that looks better. So what was bothering me is when I was prepping for the lecture today, I had moved this guide curve down to the bottom to show you how it could fail. This one should actually work quite well. Okay, so let's actually do one of these sweep along the guides. We're going to click on the Features tab and we're going to come up to Swept, Boss, or Base. You get a dialog that looks like this. So we're going to do the profile first. That's going to be your cross section. What is the constant cross section that you're going to move down along the guide? Then below that, this is the pathway. This is your guide path. We're going to choose up there. And when we say OK, we get this. And this is actually what a World War II Jeep frame side rail looks like. I actually copied the dimensions off it. Whenever I need inspiration, I go out to the barn and I look around and say, okay, what kind of junk do I have in the barn that I can torture the students with? So the car actually uses a piece of 1/8-inch thick C-channel, and the tires would be right in here. So when the axle goes up and down over a bump, it moves into this hump and right in here. Okay, now sweep along of guides, they can be a little bit problematic. Okay, these generally can be fussier than extrudes or revolves. Extrude and revolve almost always works. Okay, the problem with sweep along of guides, there's some pretty advanced stuff. And if you get the profile doubling back on itself, you can cause a sweep failure. And let me demonstrate that. So you saw that this sweep worked fine. Let me delete the sweep feature. And the reason it worked fine is that this profile went down the guide curve, the bottom swung out, so the material as it was being created was not doubling back on itself. It had plenty of radius here where it's not doubling back, and then the bottom kept swinging out. Okay, let's look at what happens when it does double back on itself. If you go back to the folder, you're going to see something called failed Jeep frame. Go ahead and download that one. And the only difference between those two is that I've moved the guide curve from up here to down at the bottom. Okay, otherwise these two are exactly identical. So let's try it just to make sure that it does in fact fail and I'm not lying to you guys. So swept boss or base, we'll choose the top one, the profile, which is your cross section. Sketch 1, the guide path. Choose sketch 2. We'll say OK. Sweep operation failed to complete. And what's going on is that as this profile moved down the curve and it tried to always remain perpendicular to the guide curve, it was upright right here, and then the top started swinging back on itself as it went through this tight curve going up. And that created an undefined solid. So a lot of times, if you're doing a sweep and you get these rebuild errors, sweep operation failed, take a look at it, try to get it so that as the profile remains perpendicular down the pathway, that you're only stretching the material out and you're not doubling back on yourself. Okay, that's probably a pretty hard thing for you guys to visualize right now, but you're going to be doing a ton of these. When we do the Stirling engine project, okay, I'm going to want to see all of the little wires that connect the Stirling engine, crankshaft going to the balloon piston, and I want to see the little twisted ends. So you're actually going to do the twisty ends, and I'll show you how to do that. So let's see, what else have we got? Let's do another sweep along a guide. Let's do a really classic example. Let's draw a spring. We'll get rid of that. Let's start another part. So let's see, I'm going to start a sketch on the front plane. And I'm going to put the cross section of my springs wire right there. As always, I have to fully dimension it. So let's see, we'll make that 1 inch. And we will use, some 1/8 inch wire. I have a fully defined sketch. My graders will not be mad at me, so that's good. Okay, now we've got to create a helix or a spiral. And we actually have a built-in feature in SolidWorks for doing that. But you have to start off with a circle to define how big the helix is going to be. So I'm going to create another sketch on the top plane. And I'm going to draw a circle from the origin right at the center out to the center of my wire's cross section. And notice that because I gave the center here and I stretched it out to the center point of my wire, that set my diameter, and I automatically got a fully defined sketch. So I've got location and I've got diameter out here, all set by geometric relations. Okay, cool. That's all nice. So to get to the Helix tool, we're going to say Insert. We'll come down a curve. And here's the Helix tool. I'm going to choose my guide curve, or excuse me, my circle that represents the center of the diameter of the spring. And we have all kinds of stuff over here that we can set if we want to. So pitch, okay. This is how far up I go for every turn. So for every 360 degrees on the helix, I go up 1/2 inch. Revolutions, I've got 4 turns on my spring. I can also change my start angle. For right now, it looks pretty good. I've got the start of my helix right in the center of the cross section of my wire. I mean, that's pretty nice. If it were over here, I could change the start angle. Okay, so now my helix is starting over there. You know, that might be useful. But I'm going to put it back at 270. So that's all you need. This is by the pitch and revolution method. You can also set the height and the number of revolutions. So if you wanted to say, give me a 2-inch spring with 4 revolutions, starting at 270, you can do it that way. All kinds of options, however you want to define it. I don't really care. We're going to say OK. And now we'll do our sweep. So we'll set our profile with a little circle. We'll set our guide curve by picking the helix. And magically, we have a spring. Okay, so when it comes, yes, go ahead.
Where was that tool?
Which one? Swept boss or base or helix?
The helix.
Okay, so go under insert, go down a curve and helix.
Fantastic, thank you.
Okay, so that's pretty much the classic spring or sweep along a guide, doing a spring. So when you guys are out in the world and you're working for Ferrari and you've got to draw, say, the hydraulic lines for the brake system or something like that, anytime you're doing form tubing, like hydraulic lines, really good time to think about sweep along a guide. Hydraulic lines, springs, any of that kind of stuff.
Transfer pipes.
Exhaust pipes, absolutely. That's where you're going to use the stuff. All right, let's see what else I've got in your lesson plan for today. So we drew the spring. There's the video if you want to see the spring drawn again. Okay. So are there any questions on that, folks? I know that was fast, but again, until you start practicing this stuff and just start using it, you know, that's when you really, really learn it.
So I'm trying to do the spiral on my own again.
Yep.
So how do I get the circle to go along with the spiral?
So the first thing you're going to do is you're going to draw the circle.
Yeah.
Okay, so I'll get rid of the sweep.
Oh, it's two separate commands?
Yes.
Okay, that makes sense.
Yeah, so you draw the circle. That sets the diameter of the helix. So draw the circle, use the helix command, and poof, then it will appear.
Okay, thank you.
So if I want to change the diameter of my helix, well, I've got it tied to the wire. So what I'll have to do is go into sketch 1. If I change how far out the center is, so that changes the diameter of my circle that generates the helix, and then the helix gets fatter.
I know that this is kind of like not with like the lesson plan, but like, so like in regular springs, you know how like the ends are kind of like flattened out. How would you do that? Like how would you manipulate the end of the spring so that like the top and bottom are flat like a regular spring?
Okay, so the technical term for that is called squaring. And let's actually do that. That's not a bad thing to do. So I'm going to sketch on the front plane. I'll do a normal 2. I'll put a box up here. I'll put a box down here. Fully dimension it as always. And let's see. And then your question is actually really well timed, because the other thing is helixes, while they're really cool and they're pretty prevalent out there, they are a bear to position in assemblies. So I should probably show you my little trick that I use for doing those. Okay, and let's see, I need to go to, okay, fully defined sketch. I'll get out of that sketch, and I'm going to do an extrude cut. This time I'm going to be a little bit slick. Instead of blind, I'm going to do mid-plane. So what it's going to do is it's going to cut in both directions. And I'll say 2 inches. Oops. Need a little more. Let's just do 5 inches. Now I really know I'm going to cut through it. Okay, so that's the cheap way. And you can see that you end up with this kind of razor edge out here. So when you go to some place like Lee Spring or one of the other big spring suppliers, yeah, this curve will actually be curved flat. Okay, that's called squaring. And then sometimes you'll want an actual flat surface. So like on a car engine, most of your springs on the last turn are flattened like this. That's called grinding. So a lot of times in a high performance application, you'll get a squared and ground spring. Let's see if we can go back into the Helix and try and, I don't think it lets you, well, you might be able to do it under this variable pitch. You'd have to play with that because honestly, I didn't prepare to go into this in this class. If you want to see it, send me an email. I'll make an auxiliary video and send out the link. And then we'll see if we can do a proper squared and ground spring.
Okay, thank you.
And the other thing, if you want to change the direction of rotation, you can go either clockwise or counterclockwise and reverse it. Okay, so that's helixes, folks. And this is how you're going to do the twisted ends for the push rods on your Stirling engine.
I have a question. How do you adjust where the helix sort of starts?
Okay.
If that makes any sense.
Yep, that was the start angle thing. Get rid of that. We'll get rid of this. We'll go in and we'll edit our helix. So right here at start angle, if I change this, see how it's spinning around right now at the bottom?
Yeah, I see.
That's how you change where it starts.
Great, thank you.
And the other one that I've used occasionally is this tapered helix. Maybe something like that. This would be, like the contacts on the top of a 6-volt battery, something like that. I've also noticed that my GTO has tapered springs like this. So if you've got a high lift car engine and you want all of these spirals to be able to go down flat or push within each other, a tapered helix is nice. Rarely used, but it's nice. It's out there. You can do it. Okay, planes and axes. That will be our next topic. So, what happens when you don't have a surface to draw on? And that is when you start relying on planes and axes. Okay, so what I'm showing you on the screen right now is something called a pipe Y. And if I just start a new part, we have our three principal planes. Nothing is shooting off at 45 degrees that's going to let me draw this thing. So we're going to do this example, and I'm going to show you how to draw this 45-degree pipe Y, and we're going to construct a bunch of planes and axes that allow me to rotate my drawing angle and then draw this branch coming off. So let's start a new part. And I've still had minimal amounts of coffee today, so we're going to start with the easy stuff. We'll start with a sketch on the top plane, and we're going to draw a standard 6-inch pipe Y that almost everybody has in their house. Okay, fully defined sketch, good to go. We'll extrude that. Let's make it 12 inches tall. Nice. But I still have nothing to draw on to make that 45-degree branch. So here's what I'm going to do. I'm going to create another plane that's offset at a distance up here. So I can come up to reference geometry. I'll click on plane. I'll choose that one. And if I choose just a plane, then I'm going to get another perpendicular plane at a distance by default. And that's what I'm seeing over here. So I'm making an offset plane at a distance of 3.9 blah blah inches. If I've got it on the wrong side, you can do the flip offset. And for now, I'm just going to say 4 inches. And that gives me a plane up here. Okay, now I'm going to drop in an axis. And the axes are going to act like a hinge pin. So axis. And I want it to be at the intersection of this vertical right plane and this horizontal plane 1 that I just created. So you remember from high school geometry, the intersection of any two planes is a line. And that's exactly what you're seeing right there. I'll say OK. And now I have another axis in place. If I want to create an angled plane, I'm going to create another plane. This time, I'll click on plane 1. Because I've only selected one thing, it says, oh, you must want an offset plane. No, I don't. That's where I'm going to come down here to this second reference. And I'm going to choose axis 4. Now, because I've chosen a plane and an axis, SolidWorks knows I want an angled plane. And when I change the angle, I can flip that plane. So standard pipe Y is 45 degrees. So I'll put that at 45. And sometimes it'll come in going the wrong direction. So as always, you can do the flip if you need to. Okay, planes are infinite, just like in geometry class. So if you grab it and stretch it, you haven't really changed anything. You just made the video representation bigger. But now, on plane 2, I have something that I can draw on that's at 45 degrees. And that's what I was looking for. So I'm going to click on plane 2 and create a new sketch. I'm going to grab a circle and I'm going to put it over here. I'm drawing it intentionally wrong, but that's okay, because for me, I find it easier to dimension things when I've got a little bit of clicking space rather than trying to zoom way in on a fine detail and trying to click on 2 points that are really close together. I'll say OK and accept it. As always, smart dimension it. So let's see, we'll do, I'm going to do 5.99 inches instead of 6, and I'll show you why in a moment. So now I've got to make sure that it aligns with the center pipe. I'm going to do that with more smart dimensions. Okay, so now I've got it centered there, and I want to make sure that I start inside the pipe, so I've got to go vertical. I'll go from the center here, and I'll go off that axis. And let's see, 4. I've got a little bit hanging out. Okay, just checking the chat, guys. Feel free to stop me at any point if I lose anyone. It's not hard, but it is all new material for you guys.
Yeah, I'm still struggling to kind of figure out how to get the planes to be set. I don't know if you could go back and.
Yeah, absolutely. So let's get rid of sketch 2. Get rid of plane 2. Because yeah, this is probably some of the weirdest stuff explanation-wise in the whole course. I mean, I've been doing planes and axes since before there were planes and axes. So it's second nature, but somebody coming in, I don't know how you learn this stuff other than do it, do it, do it. Okay. So if you want to create an offset plane, you can click on either a fixed planar face, or you can click on another plane, and that will create an offset plane, just like we did here with plane 1. Then what I did was I wanted to have an axis to revolve about. So I created an axis that is the intersection of plane 1 and the right plane. That gave me axis 4. Were you okay with getting that far? Was it just the angled plane that was throwing you, Davis?
No, I didn't make the reference axis, so I couldn't find something to revolve about.
Okay, so you don't have plane 1. You want to see that again?
No, I've got it now. I didn't add the reference geometry axis.
Okay. So I'll bring that back, and then the angled plane was the one that's a little bit odd. So I've got 3 references over here. My first reference, I'm going to choose plane 1. That automatically assumes an offset plane, but I don't want that. So I'm going to choose a second reference, and I'll choose the axis. So that makes it go right through the axis, and then I'll set the angle. Now I'm going to sketch on plane 3. Oops. And then I'm going to locate that circle so that it's on the center line of the tube. Then I'm going to bring it down so that it's inside the tube. Go. So that looks pretty good. I'm fully defined. Get out of the sketch. Now I'll extrude it. It's a little bit long, but it's just a number. That's a little short. Yeah, that looks good. Okay. So now we have something that's more like a pipe Y. If you guys remember back to the wine bottle example, because the wine bottle could have a uniform wall thickness, we were able to do a shell. Okay, we're going to do a slightly fancier shell on this one. So again, I'll go up to Features. I'll come over to Shell. This time I'm going to cut through this face, and the bottom face. I'm going to pierce all of those faces, and I want it to have a uniform wall thickness of 0.1 inches. I'll say OK. And now I have a hollowed out pipe Y. So that is how you do planes and axes. Okay, and planes and axes, admittedly, they take a little more time to get used to. So that's how you do planes at an angle, planes at an offset. Let's do another example.
I had a quick question on that one.
Yeah, shoot, Sam.
What was the reasoning for, I may have missed it, what was the reasoning for 5.99 instead of 6?
Okay. So if you get edges exactly on edges, sometimes it can cause solid model failure. So let's go back to sketch 3. Let's try and make this 6 and see if it actually works this time. See how I've got some little weird sliver face right in there? Okay, that can cause things to blow up and not work properly. So let's try and change the shell thickness. So a 6-inch pipe Y is really more like a 1/4 of an inch wall. This one is well behaved. I was seeing some weird video stuff right in here earlier. Okay, so sometimes you have, if you've got weird edges coming together and incomplete join ups like right there, you may have to mess around a little bit.
Okay.
But this would be fine to go to manufacturing, okay, because this little sliver, that may only be like the height of a sheet of paper is thick. So we don't worry about stuff like that generally. Okay, so on your homework, you're going to have to do a drive shaft. And you're going to have to put keys at a particular angle into a drive shaft. Let's go over how to put a plane on the surface of a cylinder at a particular angle. That one is not really obvious.
Oh yeah, and I did look into the multiple cylinder Stirling engine thing as well.
Yeah, Gage.
The issue with the like the constraints of the Stirling engine is that they operate in a straight line, and the T lights, you plan on using T lights, right, to power them?
Yes.
The issue with the T lights is that I don't think they would burn properly at the 45 at like a 45-degree angle if I wanted to make like a V6 engine out of Stirling engines. It'd be weird because you'd have to have them angled to have them all operating the same
Yeah,
crankshaft.
Yeah, one of the problems you'll run into with these engines is they have such little limited power. Any kind of friction just causes them to stop, unless you start playing around with seals and really good stuff.
You know, so I was like, if you did, it would just be running two flats. You'd just be running two flats and anything.
Two flats.
So I mean, like,
you could do
you'd
a
have
multi.
like a flat 6 cylinders in a row instead of having.
Well, I mean, the car I drove to work this morning has a straight 6 in it, so you could do it.
Good. It's not as cool.
Hey, my Jeep is very cool. Thank you very much. All right, so let's see. Let's do a 6-inch piece of rod. And let's get rid of, nah, I guess we'll keep that. Okay. So I got a piece of 1-inch shafting here on the screen. I've got the planes going right down the center line. But if I want to cut a keyway into the top surface by doing a cut extrude down into it, nothing I've got here is really good for that. So let's put a tangent plane right on the surface. I'm going to choose this plane, and I'll choose the cylindrical face. And that drops in a tangent plane. And now I can adjust the angle. And as I change the angle, you can see it spins around tangent to the surface. So let's see, 300. So now I've got a nice plane right on the surface, 45 degrees to this plane and this plane. So you're probably saying to yourself, how in the heck am I going to remember all of this stuff that he's just thrown at me? Well, I made you a little table to try and make it more digestible. So for example, if you want to create an offset plane at a distance, your first pick should be a plane or a flat surface, and then just specify the dialog. Rotating at an angle to a plane or flat surface, a plane and a linear edge or axis. If you want to do a mid-plane, so you're centered between two parallel planes or surfaces, then just pick the two flat surfaces or planes. And then if you want to be tangent and at a specific angle, you've got to choose the cylindrical face that you want to be tangent to, and then a flat plane or surface to set the angle. So just come right back to this little chart that I've made you. And these are the only ones that you're going to need to know for this course. Okay. So that was planes and axes. Let's do a mid-plane example. And then I'll get you on the homework because there's probably going to be a bunch of questions on the homework. And I want you guys to have plenty of time for working on stuff without struggling too much. Okay, let's start off with the Venerable Block. We'll go 2 by 4. And we'll extrude it 1 inch. Okay, so in the previous table, I showed you guys that if you click on 2 parallel faces, it will drop in a midplane. So I'm going to do that right now. We'll go up to Reference Geometry. We'll choose Plane. I'll choose, I grabbed axis 1. Okay, so now I've got the face, and it did exactly what I expected. So when I click on the face, it suggests an offset plane. I'll spin around. In the second reference, I'm going to come over here. I'll choose the other face, and then it drops in a midplane right here. I kind of like this. I find that what that does is anytime that I need something to stay centered, this is a really good way to keep it centered. So now let's drop in some holes. I'll pre-select the top face, use the hole wizard. See, 1/4 good enough. I can dimension to that center plane. So I'm going to put a dimension of 0. And this is also a good time to do another example of the use of construction geometry. I'm drawing all of this stuff that I'm doing right now inside the feature sketch. So I'll choose a line. I'm going to go from this corner to the center. Yeah, quiet. So let's imagine that I always want these holes to be, say, 1.5 inches apart. But regardless of how the block may grow or shrink in this direction, I always want it to be centered. And I always want the 1.5 inch spacing to be centered from this edge to this edge. Well, I will change this to construction because I don't want to create any edges or anything like that. And I'm going to add a relation that says these 2 lines are equal. And I will make that horizontal. Okay.
So you accidentally attached that 1.5 not to the screw point, but to the not to the hole point, but to the line
Yeah,
point.
I need to make this and this coincident, which I would have expected it to grab automatically. Okay, and that's what went wrong. Okay, so let's make some changes. Let's change this to 1 inch. Still centered. Still centered. This is one I actually use a lot. This idea of coming into the locating sketch in the feature, adding in this little bit of construction geometry. Because there's a lot of times when you'll have a mating part, you know, maybe this is an exhaust flange or something like that, and you really want to maintain a certain distance between the exhaust bolts or something like that, but you want to stay centered on the face or the feature. This works really nice. Okay, so that's mid-planes. And I could do the same thing on the 2 ends if I wanted to. I could put a mid-plane right here and then put my hole right at the intersection of 2 planes. A bazillion ways you can do this stuff. Okay, so that's mid-planes and use of construction geometry to maintain centering. If you really need a nap and you want to see that again, there's the video. Okay, so that used up our first more or less hour. At this point, let's talk homework, which will be due Monday, 8 a.m. Get rid of that. Minimize that. One of my favorite examples, coffee cup. So I did not put a material. Do not worry about putting a material selection on this. Notice that you do have a bunch of fillets on the handle. You're filleted to the body of the mug. One of the things you're going to see on this one, okay, it is absolutely okay to let parts of one geometry creating feature overlap another geometry creating feature. So if this handle goes inside the body of the cylindrical portion, that's okay. That's all good. That will not create any problems with doing mass analysis or anything like that. So let this handle go inside the body just a little bit, then this handle body will join up with the body of the mug and everything will be good. That's probably the hardest concept in this particular model. Okay, and then part 2. This is the drive shaft I was talking about. And this is where you're going to use planes. So it's a cylindrical drive shaft, 1 inch in diameter, chamfered on the ends, 1/8 inch. You've got a slot right here, and then 45 degrees off, you've got this other slot right here. So you're going to have to do a tangent plane to drop in this slot, and then you're going to have to do another tangent plane to drop in this slot. And you're going to make the second plane 45 degrees off the first one. Okay. If I was you, I would probably do this one first for the rest of the period so that when you run into issues, I can answer them. And on that note, have at it. The rest of the time is yours.
For the coffee cup, is it okay to extrude that cut, or do we need to use shelling to make the?
You can use either one you want.
Okay.
Yeah, if you want to do an extrude cut for where the liquid area is, or the liquid volume, yeah, fine.
I think it'd be easier to shell though. Just make a cylinder, shell it out, and then add the extra geometry on for the handle.
And that works perfectly fine as well. As long as you've got
Right.
uniform thickness, shell is a good option.
Does
The
it
thing with
matter?
the handle. Oh, sorry.
Now go.
Does it matter which order you select the surface of the cylinder and the plane when you're trying to add the tangent plane to the shaft?
Nope. As long as you've got a cylindrical surface to be tangent to, and then you've got a flat plane to establish the angle from, you're good.
Okay, thank you.
Also, for that mug,
Yep.
would that just be a slot swept around in a semicircle? Would that just be a slot then swept around a semicircle?
Nah, it's not going to be a slot. So before the filleting, the cross section of the handle,
Is more of a rectangle.
it is a rectangle, yes.
All right. Okay. Because I was just looking at it like, if I did a slot, it would pretty much outdo the filleting. But if you do want it filleted, then yeah.
Yeah, I do want the fillets. And where you've got, you know, a circular radius on the outside and a circular radius on the inside, and a square profile, a rectangular profile. I mean, that's kind of
So you could take the difference.
What's that?
So you could take the difference and just make that the, how can I say it, the height of your rectangle.
Yeah.
So you take the difference of the two radiuses, and that's the thickness of the rectangle. Then you put that around a semicircle.
Yep.
And do you also want us to pass in the Gantt chart with this assignment?
Yes, I want the Gantt charts on Monday, please.
And are we going to get the baggies before we start modeling it?
No, no. So the problem I had the first year when I gave out the baggies early was a whole bunch of people said, oh, I got to build it so I know what to draw. No, that's the wrong answer. I want you to plan it and design it first, then build to your plans. So the example I always use is when you guys go to work at Ferrari, you're not going over to the sheet metal rack, grab a piece of sheet metal, and start hammering it on a bench to figure out what to draw. You draw it
And
first.
Where do we get the dimensions for all the parts then? Just online?
Yeah. See, in past years, you guys have had access to all the calipers, and that's going to be a problem this year. So for the most part, you can do almost everything you need with just a common ruler. So
But we won't have the parts.
yeah. And I've even had, when we do caliper day, I gave out cans of Coke and had people measure it and draw it. So I guess what I would say is, if you guys have a couple of soda cans around, just grab, a common ruler and measure the dimensions. That's probably the best way. And then from the parts list on the website, you should be able to get all the other dimensions. So let's see. Yeah, I might have to give you guys the foam displacer disc dimensions. The safety wire, that's just flexible wire that you can form that's 0.25 in diameter. The balloon, just draw that as something like this. Don't get all wrapped around the axle with the balloon. So for example, if you just draw something like and revolve that around. That's all I want for the balloon. Don't get crazy about trying to form it or anything like that. Don't worry that it's not flexible. Don't care about that.
And then when do you think we'll have the skills we need to complete all the drawings or the models?
You have them right now, actually.
Fantastic.
Yeah, so you've gone through bodies of revolution, so you should be able to draw the cans. You've got extrusions, you've got sweep along a guide, so you can do all the push rods. Yeah, you guys are good to go to start modeling.
And then when are we going to get the bags?
So I would encourage you to start modeling, draw the cans as best you can with a ruler, draw the push rods. I'll give you some better dimension on the foam displacer discs so you have something to draw there. Boy, this COVID thing's annoying.
Did you say you were going to have to pre-make the crankshafts, or are you going to have us also design those too?
So the deal with the crankshafts is they're made out of welding wire typically, and you've got to do a 3/8 bend offset to drive the displacer up and down, and you've got to do a 3/16 bend offset to go down to the balloon. And I do have a forming tool, but that's going to be a problem. So I would say just do your best with it. And the way I did it was I just printed out the crankshaft blueprint, full size, 1-to-1 scale, and I used that as a bending template.
Okay.
Until I got lazy and then CNC'd one. But you could also go in and make your own if you want to 3D print a bending tool. I mean, that's doable.
I have a question here about SolidWorks.
Yeah, Sam.
So for some reason, like all my files are gone. Like they're still in when I go in just my file manager on my computer, they're all there in their folders. But when I open up SolidWorks, it says like file not found. And my template is not there. Should I share my screen and try to show you that?
Yeah, please. Let me stop sharing. Okay, it's all yours.
So I'm just trying to open it up here.
Yeah. Did you do a reload or something like that? Could that have...
I haven't done anything. It was working fine just like at the beginning of this lecture, and then so if I just go to recent, you see all these say file not found. And then also my template, it gives me this.
So did you rename any folders or move any folders?
I haven't done anything to it, no.
Okay, that's weird. Let's go to the little gear icon, the options.
So just get out of this.
Yeah, just cancel out. And then let's go down to file locations. Users 20, documents, SolidWorks templates 2020. That all looks good.
Is this the name of the file where it gets stuff from?
Exactly.
Oh, okay. Actually, is there a way to edit this? I might.
Yeah, double click on it.
Or should I just add?
Yeah, just add another one then. You can always
'Cause
blow that one away.
I think I removed. Yeah, see, I removed the underscores a couple days ago.
There you go. That's the whole problem.
Okay. So then I would remove this one.
Yeah,
Okay.
that's a real common problem in this class. People will move stuff or rename stuff, and then the pathways get messed up. There you go. Much nicer.
Awesome. And then does that mean my files would be there as well? Or
Uh,
I'd probably have to edit that one as well, right?
your files are all still there. It's just the pathway got invalid. So for example, try going and opening like your homework for lesson 3, something like that. Yeah, or the pillow block. Yeah, see, there's all the underscores.
Okay. So how would I edit where it gets this from?
Honestly, I wouldn't bother. But all you got to do is go in and say File, Open, and navigate over to where the file is right now.
Oh, and then grab it. Okay.
Yeah.
Or could I just change it back? Add an underscore back to it.
You can. I mean, whatever works for you. If the underscores make you crazy. Some people really get nuts over those. Again, that's me showing off being a dinosaur. Because back in the Unix days, we weren't allowed to have spaces in file pathways. So that's why it was beaten into me to use underscores.
Gotcha. All right. Well, thank you.
Yep, no problem.
I have a question.
Yeah, Ethan.
I'm trying to do the fillet on the handle of the coffee cup, and it just looks weird to me. So I don't know if I could show you.
Yeah, go ahead and show me.
So it kind of,
Yep.
I don't know.
Okay,
Strange.
so what's going on there is the order that you apply the fillets is important. So you need to fillet the handle first, then fillet the intersection between the handle and the body of the mug. So blow away fillet 4.
Yep.
Okay, now do the handle.
Okay, so you fillet like these edges?
Yep.
Right here?
Good. Yeah, and the inner ones.
See if I can. Yep. And do I hit OK, or do I do the edges of these now?
I would put those on first. So say OK.
Okay.
And now do between the handle and the body of the mug.
Yeah, that looks better.
Nice. Yeah, it should tangent propagate right around.
Yeah.
Perfect.
Okay. Yeah. Thank you.
All good.
For that shaft, those slots are to be done using the whole wizard, correct?
No, I don't care how you do it. If you want to cut extrude those, that is totally fine.
Okay, because the whole wizard wasn't allowing me to dimension the way that the drawing has it dimensioned. So, good.
No, you should be able to.
It's just when you try to dimension that way, it grabs right from the rounded edge, and you have it measured from Not the rounded edge, but right before it goes into the rounded edge.
I mean, as long as you get the geometry right, that's the big thing that I care about. All right, guys. So this is what I'm hoping that you're able to produce by the end of the course. That was a Stirling engine that I drew. And I actually unwrapped a Coke can, I put it on the scanner, and I scanned the label onto it because it was cold out and I was bored one day.
Are we going to need to do that too?
You don't have to. Some of your video cards probably won't allow you to, but it does look cool. And I put the JPEG in so that if you want to try wrapping it around, you can. But yeah, that kind of looks like swept helix right there. That might be important. And here's all the components that I drew piece by piece.
Can you show the bottom side of that Coke can?
Yep. Looks like the bottom of a Coke can. Oops. So it's got the proper indent. It's got the proper bulge right here. I mean, I may have to make some COVID concessions this year just because, I mean, last year everybody had calipers available so they could get this information. If you guys are doing it with just a ruler, you know, there's only so much I can realistically ask of you.
And then for drawing the models, does that include making the full assembly?
Oh yeah, yeah. So I've got this, and then I've got a full set of blueprints for actually putting it together, putting in the glue right there, or if you want to use double-sided tape. And then here's what's inside.
And will you give us the parts once we have the model done?
Yes, absolutely.
Okay, awesome.
As soon as you show me a good plan for how to use it, it's all yours. Yeah, as long as I know you're not doing a hack and then draw, that's the big thing I'm looking for.
Do people generally take about 3 weeks to draw the models, like you have in your example here?
I don't think it really takes that long for you guys. So I drew this in an afternoon. So I generally use a factor of 4. So it takes me a quarter of the time it'll take you guys. And that's if you're really, you know, head down, headlong into it, know exactly what you're drawing.
And could you remind me how to do the 45-degree offset for the crankshaft?
Sure. Okay, so first off, you want a 45-degree angled tangent plane, right? Okay. So if we were not all together, then where you would find that information is back in the presentation, slide 17. Rotated at an angle to a plane or flat surface, no. Tangent at a specific angle. So you would want this bottom one, but let's demonstrate it since we're here. So I'll go to reference geometry, I'll grab a plane. First, I'm going to choose the cylindrical face that I want to be tangent to. And then I'm going to choose the plane that I'm going to establish the angle from. That'll be my second reference. I'll come back to the angle, set it to 45.
Okay, thank you.
Hello.
Hey, Aiden.
Okay, look, it already looks like you've done what I'm gonna ask, but
No, keep asking. That's what they pay me for. When you guys run out of questions, I'm unemployed, and I really hate that.
okay. So I've done the first keyhole, and I'm attempting to plane out the second one.
Okay,
Can I share my screen?
sure.
So that's what I got so far. I'm trying to rotate this one a little bit up here, like
Okay,
what the blueprints are entailing.
so then set your angle. Go click on the angle button. There you go. So
I see. Is that a problem here? Two planes, only a point can be selected. Is it because I built it on top of the other plane?
no, I'm just not sure what face one is. So I tell you what, let's do this.
Face one is just the shaft itself.
Okay, so it's the cylindrical outer face.
Yes.
Okay, and then you've got the right plane. That should be fine. So yeah, you should be able to rotate that slot right around now. So go ahead and do the up and down on the angle. Why? Tell you what, just go ahead and get rid of that plane. Let's just take it from the top. So the first thing I'm curious about is, what did you shell? There's no
the
shelling
pipe.
in this part. Oh,
Oh, there isn't?
no, no shelling in this part.
Oh, okay.
Solid steel rod. So
Right.
let's get rid of that. Okay, much better. And then the ends are chamfered, not filleted. So on the edges, yeah, go ahead and get rid of that.
Right.
There you go. Much better. Okay.
Oh,
Didn't set the chamfer distance.
right.
Wow.
Okay.
Yeah, so the chamfer distance should be an 1/8 inch. Go down the bottom where it says the little D. There you go.
Okay.
Change that 0.39 blah blah to 0.125. There you go. Okay, much better. Okay, so you've got, I see that plane 1 in there.
Yep.
Okay, so you could put a slot on that. So if you choose, let's go up to reference geometry. And we'll choose a new plane.
Mm-hmm.
Now choose plane 1. Good. Go down and click on the second reference. Choose a cylindrical face. Okay. Now click on the angle so that we don't just get a perpendicular. You got to click on the little angle button. There you go. Change that to 45 degrees.
Right.
Press enter. Beauteous. So now you've got a plane that you can draw on that's 45 degrees from, in your case, plane 1.
All right. Thank you.
And then just say okay. Nice. All good.
All right. Thank you.
I have a really quick question.
Sure, go for it.
So, is the top part of the mug has an arc from the sketch, or it should be fillet?
Fillet.
Okay.
Yes. So if you look at, make sure I'm sharing my screen. So on the mug print, I'm showing that on the top drinking edge, you have a radius of 0.1 inches, both on the outside and on the inside.
Okay, thank you.
And guys, while we're looking at this print, notice that the center of rotation for the handle is not exactly tangent to the body of the mug. You'll find it's off by just a little bit. So make sure you get that center properly drawn.
I have a question real quick.
Yeah, Logan.
How do you turn off the shadows?
Ooh,
and
yeah.
it's
So
messing
let's
me up.
see. Yeah, I don't like those either. It's under view. I think it's under view, display, and then shadows and shaded mode. Try that.
Maybe I already had them turned up because it just made it darker.
Show me your screen. Let's see what.
Okay.
I think it might be real view graphics.
No, that's generally for photo rendering.
Oh, okay. It was doing some weird stuff to my screen when I had
Yeah.
that turned on. But
Now zoom out, please. You still got a reflection there. but I don't know if I'd call that a shadow. Try clicking it back on. I think you can also turn off the reflection.
Oh, there we go.
Okay.
Yeah. Sweet.
Yeah, I never cared for that bottom reflection thing either.
Yeah.
The shadows made me absolutely crazy, but for no good reason.
I have another question.
Shoot, Ethan.
Can I share my screen?
It's all yours.
Okay. I'm trying to make the second keyhole that's at 45 degrees from the
Okay,
first one.
so first off, just matter of nomenclature, they're called keyways.
Keyways, okay.
Okay, so yep.
So I made my plane. I didn't really have a problem with that, but
Okay.
I just can't, I can't get it fully defined, or it keeps getting over-defined.
Okay, so if you try to grab a line and drag it, what does it do?
Okay.
So put in a smart dimension that keeps you on the center line. And I would click on like the end of the shaft so that you go right to the center. Or you might be able to even click on axis 2. That might be a good choice.
Oh, wait. So, should I put 0?
Yes.
Or, okay. Okay. I think that's fine now.
Yeah, without being able to spin it around, it looks good.
Mm-hmm. Okay. I think that's probably good. Thank you.
Okay.
I have two questions.
Go ahead, Ryan.
First, I don't remember if we went over this at any point already, but once you already have several sketches and your three-dimensional shape, is there any way to check overall if anything is undefined?
Yes.
Or do you have to go into the individual sketches?
Nope. You can actually do it right from the part manager. So for example, in this part, if I come over here, excuse me, and I look at these sketches, if there were a little minus sign in the icon right here, then that would be an underdefined sketch. Same thing down here. I would see a minus sign over the icon in Sketch 2. That's the indicator.
Okay. And my second question was, in general, for homework assignments, do you like the blueprints all show the different dimensions that you give us so that we know what to make? If we use like for example with the slots, you say that the bottom of the slot should be 0.375 inches from the center of the circle.
Right.
But if we do smart dimension or something saying 0.125 from the outside of the circle, like is that, as long as it's
I'm good with
defined, is that
Yep.
okay? I didn't know how specific you wanted stuff.
No, I'm not going to be that crazy on you. As long as you get the geometry exactly right, that's the big thing I'm looking for.
Okay. Thank
Along with my usual rules of don't cut extrude circles, no external sketches, blah, 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 blah.
Thank you.
You mentioned the measuring tool that would allow us to see things like the centroid location and density and so forth.
Yes.
If we were to ask for those parameters so that we could check our own work before handing it in, would you be able to provide those for us?
I'm confused by the question. So for example, let's go over here. So with this bolt, it's been assigned 304 stainless steel. If I click on the Evaluate tab and I get the mass properties, I mean, there are my measurements. The mass is 0.05 pounds. So I'm not sure what you're referring to, Adam. How would you? I don't use that when I check homework.
Oh, absolutely. I was just wondering if it might be possible to get those for the homework assignments so that we could double check ourselves before handing them in.
Suppose I could. I don't have them. I've never used them. And you could still end up with a really awful part drawn with awful techniques that came out to the right mass. So I'm just not sure how that would really help you.
I was just wondering if it might be an optional double check on ourselves, but understandable.
Yeah, I don't think it'd be effective.
So I'm working on the coffee mug here, but the handle doesn't go all the way into the model. Is there a way to do that?
There are several ways to do that, Ryan. So what you could do is from these two arrows, they go back to a common center point. So I know that this arc and this arc are both concentric. Now, what you probably did was, the first order reasonable thing, which would be to say, I'm going to trim my circle off right at the very top.
Yeah.
Okay. So what if you trimmed it off right here, and because the cross section is rectangular, then just didn't extrude?
Okay.
That would be one way to handle that.
Could you trim it off along the line that's the same depth as like the shell of the mug?
No, because the shell of the mug is constantly changing. It's cylindrical in that direction.
So how would you know like how far to go in to make sure that it goes into your model, but not so far that it sticks through the other side?
Honestly, I'd spin the model around and look. So
Okay.
you've got a sidewall thickness of 280. So if I went in 140 to the center line, I'd start there, take a look, see what it looks like.
Okay.
Yeah, so just, you go from the center of this arc, you go from the top right there in 140, trim it off 140 over. I think you'd be happy with that.
So when I try to trim my circle, it just takes away the whole circle.
All right, let's try this. Let's do an example. You guys all see my screen okay?
Yeah.
So I'll do a trim. I'm holding down the left mouse button. Something like that.
And then you would just extrude that?
Yep. So now there's two things you got to be careful of when you do the extrusion. So if I do a simple extrude, I've got mine on the front plane. So it's all coming out in one direction. There's two ways you can handle that. So if you have the body of your mug centered on, in my case, axis 2, then either I can put an offset plane off this plane by half a handle width and then draw into the mug, or when I do the boss, instead of saying blind, if I say mid-plane, then it goes both directions. And now I stay centered on the origin.
The value that you put in the extrude for the mid plane is it the whole width or just the direction you, or the amount you go each direction? You know what I mean?
Well, so let's see. My handle width is 0.58. And my D1 is 0.58. So yes, it goes halfway in each direction. So whatever you type in for a number here becomes the total width of your feature.
Got you, thanks.
Another UMain alert? Come on, guys. Yeah, this is far more of the class format that I like, where I talk like half the time and then give you guys half the time to do the work, run into your problems. Those first couple lectures are like making you guys drink from a fire hose. Say, ah.
So, like, what type of Jeep do you have in your barn there?
Yes.
Oh.
So I have everything from World War II up to my 2004 Rubicon.
Oh, that's wild.
Yeah, my wife's not happy. She keeps saying I need to clean the barn. So I'm currently working on a 1943 World War II Model MB. So I just got done. I redid the transfer case, the transmission, the engine. They were just horrific. The transmission was literally something I found on a scrap iron pile. It was this giant pile of oil and muck and dirt. Somebody had taken the top off and let beach sand get inside it. So I pulled everything out of the case, washed it in diesel fuel, then power washed it with a 5,000 PSI pressure washer, dried it, painted it, and put all new components in. And it's slick. It shifts just slick and nice as can be. And it's great inspiration for test questions. So if you guys can draw an entire 1943 MB, you'll be great on the exam.
I'll get right on that.
Okay. Where is... Aha. So this is my latest toy to provide a complete and utter distraction.
I don't think that'll fit in the dorm.
Yeah. I would dearly love to bring one of these in and have it be an entire engineering curriculum.
That'd be a good time.
I do not have any question, and I have class right after this class and don't have enough time to lunch. So can I just grab the lunch really quick and leave the class if it's okay?
Whatever you guys need to do, I absolutely do not take attendance or anything else like that. If you guys got to step out, that's totally fine. That's all
Okay,
good.
thank you.
Thank you.
Just to make sure that coffee mug didn't have that material, right?
It does not, no, Sam.
Okay, thanks.
So this engine probably hadn't run in about 50 years. All right, enough of this. There's my 54 in the background, Model 3B. "70-year-old carburetors don't hold fuel worth a damn." Okay, so there is my mindless obsession.
Hi, I had a question about the cup.
Yeah, and shoot.
Do you mind if I share my screen?
Yep, absolutely. It's all yours.
Can you see it okay?
Yep.
All right,
So
so
you got the little gap going on.
yeah, how do I fix that?
Well, the question is, that's more relevant is how did you make it? So did you do a boss extrude to do the handle?
So I just took the right plane and I offset it from the front plane by the radius of the cup, like the cup itself.
Show me the top view. Let me look down into the cup. Okay, that looks fine. It's on center, so that's good. So now show me the sketch that makes the handle. Okay, yeah. So what you got going on, see those vertical constraints? Actually, no, that's not a problem. Grab the top vertical line in that sketch and drag it to the right.
This one?
Yep. So if you pull that into the cup by half a cup thickness by 0.14, then it should be completely inside and you won't have that gap. Okay,
Oh, so I should just offset it by half of what the cup thickness is. Okay.
Right. And do the same thing on the bottom.
Okay, thank you.
Yep.
I have a quick question.
Yeah, Logan, go for it.
When you shell out the cylinder and give the wall thickness.
Okay, so which cylinder? What problem are we talking about?
Sorry, for the coffee cup.
Okay.
When I made the circle and then extruded it into a cylinder, and when you shell it out and set the wall thickness.
Yep.
Does that apply to the bottom as well?
Yes, it does.
Okay.
Shelling is fine. It's 280 thickness everywhere.
Okay, sweet, thank you.
Okay, guys, so we got 3 more minutes left in this show. Are there any questions you think you're going to run into that you want to ask?
Hello again, yeah.
Go for it, Aiden.
So I'm on the cup
Okay.
This is what I got so far. I'm planning on rotating this around the axis. I think that's
Okay.
how the...
So you've got one problem immediately. So when you're going to do a body of revolution, we only draw half of the profile.
Okay.
So just put, if you draw a vertical line from the midpoint at the bottom of the cup to the other midpoint, and then just trim off all the other jazz, then you'll be able to spin it around.
Okay.
Okay, but I think I interrupted your question anyway.
Well, I mainly just wanted clarification that I was going about this okie dokie.
Well, partially dokey.
Okay, let me just kind of go through here and get rid of everything on that side.
Okay.
And there we go. I just got to define it.
Yep. So the other thing is you got to locate it in space. Yep, there you go. Good.
I'll just sit it on the plane there.
Okay.
Why is this line?
So if you don't know what to do, grab it and try and drag it.
Yeah,
Okay.
I see. There we go.
Almost. Still underdefined.
Not there. Oh, there it is.
No. So drag that line to the left again. I was really liking what you were doing there. Okay, good. Okay, just stop and leave it right there. Okay, now smart dimension it back to the vertical axis 1. There you go. Now make that 0.
Oh, I think we got too many going on here, so. Let's kind of get rid of this one. Just smart dimension that to the axis. Okay.
Nice.
Fully defined. Thank you.
Yep.
Axis of revolution is this one. Here we go.
Okay, guys, I hate to tell you, but it's that time again. I know, your favorite class of the whole week. So any last questions before I shut the Zoom session down? Okay. Then I will see you guys next week. Drop me an email if you have questions. Thanks. Bye.